Assalamu alaikum. My name is Amna Fayaz. I am Department of BS Biotechnology. Today my presentation topic is hydrogen fuel. First of all, introduction. Hydrogen is a clean fuel. When consumed in a fuel cell, produce only water. Hydrogen can be produced from a variety of domestic resources such as natural gas, nuclear power, biomass and renewable power like solar and wind. These qualities make it an attractive fuel option for transportation and electricity generation applications. It can be used in car, in-house for portable power and in many more applications. Hydrogen is an energy carrier that can be used to store, move and deliver energy produced from other sources. Today, hydrogen fuel can be produced through several methods, and the most common method today are natural gas reforming, a thermal process, and electrolysis. Other methods include solar-driven and biological process. Now move towards the next slide. Properties of hydrogen. Physical properties of hydrogen fuel. The hydrogen gas is a colorless, odorless, and tasteless in nature. It is a combustible gas but not a spotter of combination. It is lighter than air and insoluble in water. It has an atomic mass of 1.008 amu and an ionization enthalpy is 1312 kilojoule mole per. Now move towards the next slide, and next is chemical properties. Chemical properties are highly determined by the bond dissociations enthalpy. Hydrogen molecule form an HH bond, and this single bond has the highest bond enthalpy between two atoms of an element. Hydrogen is inert at room temperature due to its high bond enthalpy, and therefore it is prepared at very high temperature in an electrical arc or under ultraviolet radiations. Hydrogen has an electronic configuration of 1s1, and so it can react either by losing an electron and forming an H plus ion, or gaining an electrons and forming an H negative ions. Hydrogen shares electrons with other elements and form a covalent bond. Now move towards the next slide. Here is the diagram you can see. Now hydrogen production. Natural gas reforming gasification. Synthesis gas is a mixture of hydrogen, carbon monoxide and a small amount of carbon dioxide is created by reacting natural gas with high temperature steam. The carbon monoxide is reacted with water to produce additional hydrogen. This method is the cheapest, most efficient and most common. Natural gas is reforming using steam accounts for the majority of hydrogen produced in the United States. Unusually, incorporation, carbon capture and store in the process can produce hydrogen with lower carbon dioxide emissions. A synthesis gas can also be created by reacting coal or biomass with high temperature steam and oxygen in a pressurized gasifier. This converts the coal or biomass in gaseous components, a process called gasification. The resulting synthesis gas contains hydrogen and carbon monoxide, which is reacted with steam to separate the hydrogen. Now move towards the next slide. Electrolysis. An electrical current splits water into hydrogen and oxygen. If the electricity is produced by renewable resources such as solar or wind, the resulting hydrogen will be considered renewable as well as has numerous emission benefits. Power to hydrogen projects are taking off using excess renewable electricity when available to make hydrogen through electrolysis. Next point is biomass derived liquid for reforming. Renewable liquid fuels such as ethanol are reacted with high temperature steam to produce hydrogen near the point of the end use. Now move towards the next slide. Next point is biomass conversion. Biomass is converted into sugar-rich feedstock that can be fermented to produce hydrogen. Next point is thermochemical water splitting. High temperature generated by solar concentrator or nuclear reactors drive chemical reaction that split water to produce hydrogen. Next point is photoelectrochemical water splitting. Photoelectrochemical system produce hydrogen from using special semiconductor and energy from sunlight. Now move towards the next slide. Here the diagram for the production of hydrogen path. Next point is storage of hydrogen. Hydrogen storage is a key enabling technology for the advancement of hydrogen and fuel cell technologies in applications including stationary power, portable power, and transportation. Hydrogen has the highest energy per mass of any fuel. However, its low and medium temperature density result in a low energy per unit volume, therefore requiring the development of advanced storage methods that have potential for a higher energy density. Next point is hydrogen can be stored physically as either as gas or a liquid. Storage of hydrogen as a gas typically require high temperature tank 350 to 700 bar tank pressure. Storage of hydrogen as a liquid required karyokinesis temperature because the boiling point of hydrogen at 1 atmosphere pressure is minus 252.8 degrees Celsius. Hydrogen can also be stored on the surface of solid by adsorption or within solid by absorption. Now move towards the next slide. Here how hydrogen is stored. Diagram, you can see this diagram. Now move towards the next slide. Fuel cells. A fuel cell uses the chemical energy of hydrogen or other fuels to cleanly and efficiently produce electricity. If hydrogen is the fuel, the only products are electricity, water, and heat. Fuel cells are unique in terms of the variety of their potential applications. They can use to wide range of fuels and feedstock and can provide power for systems as large as a utility power station and as small as a laptop computer. Fuel cell can be used in wide range of applications, providing power for applications across multiple sectors including transportation, industrial, commercial, resident building, and long-term energy storage for the grid in reversible system. Now move towards the next slide. Fuel cell has several benefits. It's over conventional combination-based technology currently used in many power plants and vehicles. Fuel cells can operate at higher efficiencies than combustion engines and can convert the chemical energy in the fuel directly to electrical energy with efficiency capable of exceeding 16%. Fuel cells have lower or zero emission compared to combustion engines. Hydrogen fuel cells emit only water, addressing critical climate changes as there are no carbon dioxide emissions. There also are no air pollutants that create smoke and cause health problems at the point of operation. Fuel cells are quiet during operation as they have few moving parts. Now move towards the next slide. Here the diagram of fuel cell. Now move towards the next slide. And next is the applications of hydrogen fuel. Hydrogen is used in many industrial processes. Nearly all of the hydrogen consumed in the United States is used by industry for refining petroleum, treating metals, producing filters, and producing fuels. U.S. petroleum refineries use hydrogen to lower the sulfur content of fuel. Now move towards the next slide. And here the hydrogen fuel cell diagram. You can see this diagram. Now move towards the next slide. Hydrogen is used for exploring outer space. The National Aeronautics and Space Administration began using liquid hydrogen in the 1950s as a rocket fuel, and NASA was one of the first to use hydrogen fuel cell to power the electricity on spacecraft. You can see this diagram. Now move towards the next slide. And burning hydrogen for electricity generation. Insert is using hydrogen as a power plant fuel is growing. In the United States, several power plants have announced plans to operate on a natural gas hydrogen fuel mixture in combustion gas turbines. Next point, one example is the 485 megawatt long rigid energy generation project facility is with a gas-fired combustion turbine that will turn on the 95% and natural gas 5% hydrogen fuel blend in a gas turbine with a plan to eventually use 100% green hydrogen produced from renewable resources. Another example is Intermountain Power Agency planted conservation of an exciting coal-fired power facility in use of a combined cycle gas-fired facility that could initially use up to 30% hydrogen and eventually use 100% greenhouse. Now move towards the next slide. Hydrogen use in vehicles. Hydrogen is considered as alternative vehicle fuel under the Energy Policy Act of 1992. The insert in hydrogen as an alternative transportation fuel stems from its stability to power fuel cell in zero emission vehicles with no emission of air pollutants. Its potential for domestic production and the fuel cell potential for high efficiency. A fuel cell may be 2 or 3 times more efficient than an internal combustion engine running on gasoline. Hydrogen can also fuel internal combustion engines, but burning hydrogen results in nitrogen oxide emission and is less efficient than used in fuel cell. Several vehicle manufacturers have light-duty hydrogen fuel cell vehicles available for lease or sale in California, where there are public hydrogen fueling stations. Test vehicles are also available in limited number to organized with access to hydrogen fueling station. Now move towards the next slide. Here is the diagram you can see, and move towards the next slide. And advantages of hydrogen fuel. Environmental benefits of hydrogen fuel. The primary driver behind the adoption and acceleration of hydrogen fuel in heavy-duty mobility is its potential as an eco-friendly substitute for fossil fuels. Meeting ambitious net zero targets remain a significant challenge, if not an impossibility, without a visible alternative to power the engines that drive modern commerce and civilization. Current solar and wind technologies are not yet advanced enough to fully replace fossil fuels, particularly for powering heavy-duty mobility vehicles. Now move towards the next slide. Improve performance and reliability. Hydrogen power may be the key to reducing a vehicle fleet's operational cost compared to battery power or internal combustion engine counterparts. Hydrogen power vehicles offer comparable if not superior performance and reliability in a number of ways. Fuel cells can reduce costs associated with changing charging and magnetic battery, which results in reduced labor time, space, and peak power demands. Now move towards the next slide. Unit run longer than lead acid batteries. Next point is unit fuel up much faster than a battery charge, reducing downtime. Hydrogen fuel cell technology is extraordinarily resistant against harsh conditions, capable of remaining operational in some zero weather. Now move toward the next slides. Challenges of hydrogen fuel. Production challenges. Conventional means of generating hydrogen fuel are energy intensive and tend to rely on fossil fuels. Even so, the emergence of green hydrogen could negate the issue entirely. Next is distribution challenges. Likewise, distribution hydrogen will require extensive infrastructure and networks as well as specialized transportation. Next is limited infrastructure and lack of refueling stations. Currently, hydrogen fuel infrastructure is insufficient for widespread adoption. However, with each passing year, these networks are growing rapidly. Now move toward the next slide. And high cost of production and storage. As mentioned, conventional hydrogen fuel for fuel production as latent cost, energy and storage issue. Next point is latest research and development. Now move towards the next slide is improve catalyst for fuel cell. Research have been working on developing more efficient and cost-efficient catalysts for fuel cell. For example, platinum-based catalysts have traditionally been used. Efforts are being made to reduce or replace the use of platinum with alternative material like non-precious metals or non-metal-free catalysts. These advancements aim to enhance the performance of fuel cells, making more commercially viable new material for hydrogen storage. One significant challenge in hydrogen fuel technology is efficient and safe storage of hydrogen. Research has been exploring new materials and techniques for hydrogen storage. Some promising approaches include using metal hydrides, porous materials like metal organic framework, carbon-based materials such as graphite and chemical ammonia and liquid or organic hydrogen carrier. Next point is advanced in production method. Researchers are actively working on sustainable and cost-effective approaches for hydrogen production. Advances have been made in water electrolysis, steam methane reforming and biomass gasification. Integration of renewable energy resources such as wind and solar power into the production processes have enabled the generation of green hydrogen with reduced carbon emission. Overall, the latest research and development in hydrogen fuel technology has focused on improving fuel cell catalysts, exploring innovative material for hydrogen storage and advancing production method. Now move towards the next slide. You can see this diagram and now move towards the next slide. Future outlooks. Hydrogen fuel holds significant potential in reducing greenhouse gas emission and meeting global energy demands in future. As a clean and versatile energy carrier, hydrogen can be produced through various methods such as electrolysis powered by renewable energy sources or by reforming natural gas with carbon capture and storage. Next point. One key advantage of hydrogen is its ability to be stored and transported effectively, enabling its use across different sectors, including transportation. Hydrogen fuel cells can be powered electric vehicles, offering long-range capabilities and quick refueling times. Now move toward the next slide. Moreover, hydrogen can contribute to decarbonize the power sector by serving as a storage medium for renewable energy. Excess renewable energy generated during low demand periods can be used to produce hydrogen through electrolysis, which can be converted into electrical through fuel cells or combustion when needed. Nevertheless, many countries and industries are already investing in hydrogen technologies and infrastructure. Governments are implementing supporting policies and private sector companies are undertaking research and development efforts to accelerate the hydrogen economic growth. Now move toward the next slide. Here the diagram future outlook of hydrogen fuels. That is all my slides. Thank you for listening to me.